Using performance, tracing, and profiling, developers are able to answer high-level service health questions such as, are the messages being put in my queue being processed, all the way down to questions at the code level. Today we're going to walk through a variety of updates to performance which help answer these high-level, aggregate questions about application health. After this, we dive into updates to profiling, which allow profiling to be used in a wider variety of situations with less restrictions. Different types of developers have different sorts of questions they're trying to answer with the telemetry they collect about their application. The problems that face mobile developers vary from those facing backend engineers, front-end web developers, and AI specialists. With this in mind, we are refocusing Sentry's performance views on the domains backend, front-end, mobile, and AI. This allows us to immerse ourselves in each of these communities, solving the real-world problems facing us developers. Through this domain-focused lens, let's look at some of the features that are landing in performance. One of the superpowers of Sentry's performance views is that they're based on real user metrics. Other tools tell you how your application is performing in a cleanroom environment. Sentry's performance can tell you whether your front end is behaving poorly for specific users, on specific browsers, in certain regions. We recently received a report that Sentry was running slowly for some users in Istanbul. With the new Geo region selector, I'm able to drill down to the region Western Asia, and I can see that on a 30-day timeline, requests are about 300 milliseconds slower than the global average. With this information in hand, we deploy additional servers near Istanbul, and we can observe that requests are now as fast as other regions. We had another front-end problem reported recently that Sentry's real user monitoring features helped us sort out. Several people were reporting that Sentry was slow to load. Using the browser selector in Web Vitals, we saw that even though Chrome and Edge had a similar time to first byte, Chrome rendered its largest component seconds slower. This info helped us identify a performance issue affecting one browser, but not the others. Sentry's query monitoring helps you investigate your database performance in terms of throughput and duration, so that you can prioritize fixing the parts of your application where it spends the most time talking to the database. Up until recently, we've only supported SQL databases such as Postgres and MySQL. We've now added support for MongoDB. In the query view, you can select MongoDB as the system, as well as selecting specific operations and collections that you wish to view queries for. As with SQL, we group together similar MongoDB queries, which you can use to drill down, find exemplar spans, and see where queries are used in your application. This information in hand, you can make decisions about where to optimize performance. MongoDB spans are already instrumented by many of Sentry's SDKs. You should go ahead and try it out. In the mobile performance view, we've combined app starts and screen loads and added the new view, screen rendering. Screen rendering shows you if specific views within your application are presenting users with slow or frozen interactions, and how frequently these problems are occurring. From here, you can dig into exemplar traces and profiles to identify the root cause of the frozen frames. With the introduction of screen rendering, a mobile developer can now understand the real-world app performance, from how fast the app starts, to how quickly and snappy it navigates between screens, and finally, the real-world perceived visual performance while interacting. We've seen how performance lets you identify broad, aggregate changes in your application behavior. I'm now going to hand it off to Indrajit to talk about how continuous profiling allows you to investigate application behavior at a lower level.
We launched Sentry Profiling just over a year ago to provide developers with deeper, function-level visibility into the performance of their code. It works well for measuring the performance of common operations like handling an API request or loading a page in a web or mobile app. However, there were two key limitations that made profiling more challenging to use in some situations. First, a profile could not be longer than 30 seconds in duration, and second, profiling was tied to the lifecycle of a transaction without any independent control over when profiling data was being collected. Today, we're previewing an evolution of profiling, continuous profiling, which addresses these gaps. For scenarios where you need to measure the performance of a long-running task, like running a build script or training a machine learning model, continuous profiling supports arbitrarily long profiles. Whether your task takes seconds or hours, you can leverage profiling to find your bottlenecks. You now also have complete control over when the profile is running with the addition of new start-stop APIs in the SDK. The profiler lifecycle is now tied to the process rather than individual transactions. Instead of collecting separate profiles for every transaction, you can start a long-running profiling session that captures everything that's happening with no data gaps. Let's take a look at an example use case. Here, we're looking at a profile of the MyPy type checker on a Python code base. MyPy takes almost 2 minutes to finish running, so this is something that wouldn't have been possible previously with the 30-second profile duration limit. On each span, the profile button takes us to a flame chart that shows the code that was running during that span. We can see here that the MyPy type checker has been spending a lot of time trying to type check one particular expression. The call stacks indicate that the MyPy type checker might be struggling to parse a dictionary expression, which given the call stack pattern, looks like it could be either a very large expression or a recursive type expression. This reveals an optimization opportunity that was previously not visible to us, but it represents almost a fifth of the time we spent type checking this code base. Continuous profiling is currently in beta and supported in the iOS, Python, and Node.js SDKs, with more SDKs to follow soon.
With the changes that have been landing recently, Sentry's performance product makes it easier for developers to identify trends in application behavior, while at the same time providing tools to dig into nitty-gritty, code-level operations when necessary. I encourage you to try out performance and tracing and see why many developers consider it not that bad.